Hi, this is King of Review. Here we have to find two different solutions to this long logarithmic and exponential equation, and then we need to multiply them together. So to start, I notice right away that the first two pieces of this equation are sort of reversed from each other. We have x to the power log of 2 and 2 to the power log of x. Now there's a very important property of logs that says if you have some base a to the power log base b of c, this is exactly equal to c to the power log base b of a. So basically we can switch a and c, the number inside the log in the exponent and the base of the exponent, and we get something exactly equal as long as the two logs have the same base. That's exactly what's happening in these first two terms. So in particular, x to the log base 10 of 2 is equal to 2 to the log base 10 of x. So I'd like to replace this x to the log base 10 of 2 with 2 to the log base 10 of x, since I see that same term 2 to the log of x later on in the problem. If I make that switch, I get 2 to the log of x times 2 to the log of x minus 6 times 2 to the log of x plus 8 equals 0. Now since there's so many 2 to the log of x's in this problem, it'd be nice to introduce a variable y that equals 2 to the log of x, so that I can replace that term with a y wherever I see it. I'll have y times y, which is y squared, minus 6 times y plus 8 equals 0. This is a simple quadratic equation that I can solve by factoring. I know y times y is y squared, so I need two numbers that multiply to give me 8 and add up to negative 6. Two numbers that do that are negative 2 and negative 4. By solving this equation, I get that y minus 2 equals 0, or y minus 4 equals 0, which tells me that y is either equal to 2 or 4. But of course, I didn't want to solve for y, I wanted to solve for x. So let's see. If y equals 2, that means 2 to the log of x is equal to 2. Well, the 2 on the right side of the equation has an exponent of 1, so that means that the log of x has to equal 1, since the two exponents have to be equal. Now to get rid of this log, which remember has a hidden base of 10, I can use another property of logs that says any number b to the power log base b of x, the b's and the log of b's cancel out and we're left with x. So if I want to get rid of log base 10, I need to raise 10 to the power of both sides. 10 to the log base 10 cancels, and I'm left with just x. 10 to the first is 10. So there's one solution for x. I can do the same thing for 2 to the log of x is equal to 4, the other solution for y. Well, let's use the same logic as last time. I know that 4 is 2 to the second power, so since both of these bases are 2's, the log of x has to match 2. If the log base 10 of x equals 2, I can raise 10 to the power of both sides. The 10 and the log base 10 cancel, and 10 squared is 100. I now know my two solutions for x. I'm told beta is greater than alpha, which means 10 is alpha, 100 is beta, and if I want to know alpha times beta, that's the same thing as 10 times 100, which is equal to 1,000. So there's our answer. Thanks for watching.